We are in Algebra 2. Today's lesson is 1-7, binomial special products. Today's date is Friday, September 4th, 2020. Our objective today, who wants to read that? Jenny, yes.
Find the product of difference of square and perfect squares.
There it is. Yeah, so we're going to do products today. We're doing multiplication, and we're going to do two things: difference of squares and perfect squares. So here we go. First, we should define what a conjugate is. So it's changing the, has anyone ever heard of the conjugate before? Maybe in Algebra 1? I don't remember if we've done this in Algebra 1. This might be new stuff finally. No? All right, so the conjugate is changing the sign in the middle of the two terms. So 3x plus 1 will turn into what? Charles.
3x minus 1?
There it is, 3x minus 1. Precisely. So I'll be using this term conjugate a few times throughout today's lesson and for the rest of your mathematical career, like even AP Calculus, we talk about, oh yeah, just try multiplying by the conjugate. It's kind of the magic fix-all to get rid of things you don't like. Difference of squares, okay, the first part of our objective today. Difference of squares means I'm multiplying by a conjugate pair. So look, I have a minus b, and the conjugate of a minus b is a plus b. I changed the sign. If I multiply by a conjugate pair, that by definition is a difference of squares. I'll also highlight that you should be thinking of how to go backwards with everything that you're doing. In this unit, we're only going forwards, I think. Pretty sure. And then the next unit, we're going to go backwards. We're going to be doing factoring. So how do you identify that it's a difference of squares and go backwards? Be thinking ahead of time. All right, so anyway, how do we do the multiplication? I will do the first square for you guys. Oh, Charles already has an idea. Yeah, what's your idea, Charles?
I think that it would be, like, wouldn't they cancel out to 0? Like, oh wait, never mind.
Things do cancel out though. No, that's good that you're seeing ahead.
Yeah, that would be a squared and then a 0. Because b, a and a would be a squared, and then b minus b would be 0.
Yep. Yeah.
And then the other two would just be ab, except one would be negative.
Yeah, so let's do that workout so we can see what Charles is seeing. So in this first cell right here, Charles even said that this is going to be a squared. A times a, they're both to the power of 1, right? A times a, you add their powers and it's a to the power of 2. Okay, what about this cell on the right over here? What is that? With a quiet raised hand. Wyatt?
Would that be negative AB?
It is indeed negative AB. What about in the bottom left down here? A times B. Help me out, guys. I need more than just Charles and Wyatt. Jose?
It would just be AB.
AB, perfect. And we'll give this one to Andres down in the bottom right. That's right here.
Negative B squared.
It is indeed negative B squared. Okay, then our rule whenever we have a general rectangle is we just add everything together. So if I'm listing out all my work, and you can skip a step if you want, but listing all my work, I have a squared minus AB plus AB minus B squared. Charles correctly saw that something was going to cancel out, and you guys can hopefully follow along with us. Now, negative AB and AB, those are opposites of each other. They cancel each other out, and our final answer down here is a squared minus B squared. So let's actually write that again up here. This is going to be a squared minus b squared. This is a formula that would typically be just given to you in a textbook. Say, hey, memorize this. I wanted you guys to know where it came from. It comes from just multiplying them out. Like the b squared or the ab terms do indeed cancel out. So this is a shortcut. And if you ever see a conjugate pair like this, and they might not be a and b, it might be like 2x right there for the a, it might be 3x squared for the b. Something might be in those terms, but if you see this general form where you're multiplying conjugates, take the first thing, square it. Take the second term, square it. Put a subtraction sign in between there, you're done. That is your shortcut. So if you want to do it all out and do the same general rectangle over and over again, you can, but I'm trying to show you guys a faster way of doing this. Okay, so let's do this this rule right here in words. So I guess I could say over here on the right or left, sorry. This is the rule in words. So if you are multiplying, what are these two things called again for these two blanks right here? I've said it like 3 times or so. I can't tell if Andres has his hand raised for this question or the previous question. I'm going to go ahead and lower it, and you can raise it again if it is for this question. What are these two things called right here? We'll give it to Charles, but you're going to have a cooling off period of not being able to answer. Sorry, Charles. This one, go for it.
Conjugate pair.
They are indeed conjugate pairs. Conjugate pairs. If you're multiplying conjugate pairs, and sometimes it's hard to identify, but it just means one of them has a plus, one of them has a minus, but they're the same numbers, the same terms, first and second. So if you have that, then you're going to do the following. You're going to do what to the first term? What do we do to that first term? And then you're going to subtract the what of the second term. What operation do we do to A? What thing right here do we do to A?
Exponent.
Next time a quiet raised hand, but it is an exponent of what, Gunnar?
You cut out.
Oh, sorry. An exponent of what?
A.
So A is to the exponent of a 2, and we call that doing what to A?
Squared.
Squared, yep. So come down here, we'll say, I think it might have just cut out again. No, you guys can hear me? Okay. Then we square the first term, then we're going to subtract the square of the second term. Okay, let's try to utilize this shortcut. It saves us so much time. If you ever are in a tight spot, like ignore this lesson and do the general rectangle like we learned in our last lesson. But this is a cool shortcut, and it will save a ton of time over the rest of your mathematical career, because you're going to be like math teachers and math test takers or math test creators love putting these on here, because if you know the shortcut, it will save you time. It's on the SAT also. Difference of squares. Look, this is a conjugate pair. It's the same term, 6y to the 5th, 6y to the 5th, 4, 4. The only difference is different signs in between. This is a pair of conjugates, or a conjugate pair. So I'm going to square the first, then I'm going to do a minus sign, and I'm going to square the last. Oop, too far back. Okay, but squaring things might be a little bit difficult, right? So we might have to do some scratch work. How do I do 6y to the power of 5, and I need to square that? What does that even equal to? Can someone help me out with that one? Sorry, Charles, you're still in cooling off period. Yeah, Jose.
Would you just multiply 2 by 5?
Yes, so it's going to be y to the power of 10. What about the number out front?
No, you multiply it 2, right?
Not quite. So this one is actually going to be, so the 2 and the 5 interact because they're both exponents, but the 6 is not an exponent. So I don't multiply. I actually do to the power of 2.
Oh, so it'd be 6 to the power of 2 and then y to the power of 10, right?
Exactly. Yeah, 6 to the power of 2, y to the power of 10. And what is 6 to the power of 2, Jose?
36, right?
Yep, 36, y to the power of 10. Why am I doing this? Why am I squaring this first term? That's our shortcut in words and in our formula up here. We need to square our first term, and we have that. So I'm going to come back here and say, okay, 36y to the power of 10. And then it says, in terms of my words, so I squared my first term, done. I'm going to subtract, so subtract the square of the second term. The square of the second term, I need to square 4. Oh, I can do that for you guys. 16, done. Box it. That's how fast those go. There's no, I mean, it would take quite a while to do this general rectangle. I'm not saying it can't be done, but this is our shortcut. If you want to verify this, you can go ahead and write out your rectangle again, but there it is. So we'll be seeing quite a few of these in the homework tonight, but we're also going to be doing a different type of shortcut. So I know that memorizing all these shortcuts might be tedious. Again, if you don't know how to memorize these shortcuts, just do the general rectangle over and over. It's the hardcore way of you will get the correct answer. It's just a lot more work. Okay, what if I have this term, sum of squares? And by the way, does anyone need to raise their hand to get more time to write down notes? No hands, no hands. Okay, so sum of squares. What if I have something that looks like this? There's no conjugate pairs. I just have a plus b, and there's a square on the outside. That's a sum of squares. And by the way, this has another form that you might need to pay attention to. It might look like this. It might look like a plus b, a plus b. It might look like that. It's the same formula. We want to figure out what is this formula, the shortcut. So here we go again. We're going to figure out where the shortcut comes from. I don't want to just give it to you. I'm going to say, okay, up here, I have an a plus b. I have an a plus b. What's going to happen here? Who's going to fill in these boxes for us real quick? I'll try calling people I haven't called on before. Well, I haven't called on Andres very much. Yeah, go for it, Andres.
So the first one's going to be a squared.
It is indeed a squared. Cool, I'll call on someone new. Cohen, do a top right box, top right cell right here.
It's going to be AB.
Perfect, AB. What about bottom left, Cohen?
AB.
Perfect, it's AB again. Sergio, what about bottom right?
B to the power of 2.
Yep, b to the power of 2, b squared. Cool, and then we just add them all up again, right? That's what it means to have an area model or a general rectangle. We add everything in here and that's our answer, combining like terms eventually, but I have an a squared plus ab plus ab plus b squared. I have two of these ab terms, so when I combine my like terms, I say a squared plus 2ab plus b squared. So as the formula goes, that's kind of hard to memorize. But there it is. So I'm going to come up here and write it out. A squared plus 2ab plus b squared. I can try drawing like a perfect rectangle here. Are you guys ready for this? Oh, that's close. Okay, so one thing that is important to point out before I start talking about what this rule is in words. So I come over here, this is the rule in words again. Is that when I say AB, this part without doubling it, this is just called the product. If I say A times B, that word is called a product. It means multiply. Multiply A times B. Okay, and this is a harder rule, but a very useful rule. What?
Can I answer the fill in the blanks?
You may, yeah, go for it.
So if you are squaring a binomial, square the first, double the product, and square the last.
Double the product. I can't spell product. And square the last. There it is. Yeah, thank you, Wyatt. Andres, question, go.
So for the answer of the sum of squares, does it have to be in order, like a squared plus 2ab plus b squared, or can it be out of order?
Mathematically, you're correct if it's out of order, but if it's in this order, it's a little bit easier to verify your work with your peers or with me because everyone's going to be using the same order. So yeah, mathematically you're correct.
Have to.
You don't have to, no.
Okay.
Because everything is degree 2, because remember, a is to the power 1, b is to the power 1, so this entire term is a degree 2 term. You'd add all the powers. This is a degree 2, this is degree 2. In terms of standard form, you can rearrange these however you want, and it's still in standard form. They're all degree 2.
Okay, thank you, Mr. Sindel.
Yeah, you're welcome. Good question. Okay, so this is the part where I stop letting you copy down the notes. So sorry if you're copying down the notes. I'll show it to you in a sec again. But this is the part where you really need to have the visual. So, and this is true, by the way, this will put kids to sleep. So I don't know if you have young kids at home, Jade, I know you do. But if you need to put a kid to sleep, this is what you do. You put them in your arms and then you just recite this to them. Square the first, double the product, square the last. I swear, I did this to Riley and it put him to sleep. Everyone with me. I'm looking at your cameras now. Let me look at everyone's cameras. I'm looking at everyone's cameras now. Turn your camera on, everyone with me. Stand up, hold your baby. If you need to hold like a water bottle or something to actually practice, maybe Jade can actually go grab an actual baby, I don't know. have a baby in your arms. Are you guys ready? Everyone up, come on, stand up. You guys are sitting in your chairs. Stand up. Here we go, ready? Square the first, double the product, square the last. Again, square the first, double the product, square the last. You need to be saying it with me, even though your microphone might be muted. I mean, at least say it out loud. Get the rehearsal down. Square the first,
Square the first.
double the product, square the last. Again, come on, rock your baby. Square your first, double your product, square the last. Last time, square the first, double the product, square the last. Okay, so I think that's like a spell. This water is now sleepy water, and it will put people to sleep. All right. Memorize that. It is important. It will save you time. Again, if you don't like memorizing these shortcuts, then you
Wait,
can.
do you? Oh, question, Mr. Snow.
Yeah.
Do you have to? What is it called? Do you have to say that while you're rocking?
Yes, you do. Yeah, saying it out loud is how you put the baby to sleep. Just rocking them is pretty good, but like if you say that, they're like, oh, that's algebra 2, that's math. Oh, they're out. All right. So I'll give you some more time to copy our notes started. All right. So there's 3 things that we have to do. Let's do them all kind of individually, and then we'll put them all together at the first. So we're gonna square the first. We're gonna find the product. And then we're going to double the product. And then we're gonna square the last. Square the last. Or I guess the second, right? I'll say square the last so it matches with us. Square the last. Okay, let's square the first. That means I have 4a to the power of 7, and I'm going to square it. Who can help me with that? It's very, very similar to what Jose did. So Jose, sorry, you already did that last squaring one. Sad face, I know. Squaring the first. How do we do that? 4a to the power of 7 squared. Sergio, take it away.
You do 7 times 2.
You do?
14 as a power of 14. So then it's 4 to 4 times 4 equals 16. So 16 to the power 2. So power 14.
Yeah, you got it. Nice. Thank you. I need someone to find the product. And again, when I'm taking the product, I need to do the product of -9 times 4a to the power of 7. Include the sign in front of it. That's the most common mistake when you're finding the product of those 2 terms. Wyatt?
Can I find the product? Mr. Sadell, can I find the product?
It cut out there. Can you say it one more time? Sorry.
Do you want me to find the product?
Yes, please.
So the product would be -36a to the power of 7, and then you have to double it, which would be -72a to the power of 7.
There it is. So doubling the product is -72a to the power of 7. And then finally, thank you, Wyatt, we're going to square the last. It's a nice, easy one. Who hasn't participated very much? I haven't heard Gunnar for a while. Our last term is -9, Gunnar. We're going to square that.
-9 squared would be just, so it'd be -9, so you put -9 and then -9 squared is -18 squared.
-18 squared? No. What's just 9 times 9?
9 times 9 is 81.
81. And then is this going to be positive or negative?
Negative.
Not quite. So it's going to be a negative times a negative, and negative times a negative is a positive. Cool. So there it is. Thank you, Gunnar. Then we put all these together, and we're done. So let's write this out. We have 16 a to the 14th minus 72 a to the 7th plus 81. I did a plus because this is a positive. It wasn't a negative. And there's our final answer. We boxed it. I'm hoping that most of you guys can do all of this in your heads. I know that this one is the hardest one to do in your heads, but these you can start doing in your heads for sure, the first and the last. Doubling the product I know is hard. Even I sometimes struggle with doubling the product. I do product, okay, then times 2, then we're good. Cool, there's your shortcuts. Hopefully these shortcuts are eventually going to turn into mental shortcuts. That's all we have for the notes.